Chapter-wise list of all my videos is available at this point. For DVD, pen drive, please write an email to me. These videos, they do not require internet, they play offline, there is no problem of buffering. And please subscribe to my channel for regular updates. Thank you for your support once again. We will now take up the case of a train crossing a bridge or two trains crossing each other. We'll start by taking the case of a train crossing a bridge. Suppose this is a bridge that is standing along the railway track, and let the length of the bridge be L. Now if a train is positioned in such a way that its head is just touching this edge of the bridge, and let the length of the train be L, and let the speed with which the train is moving be v meters per second. If the train is positioned in this position, this head is touching this edge of the bridge, then our time counting starts. After some time, the position will be this. This will be the bridge of length L, and this will be the train length L, and its tail will be touching this end of the bridge. Our time counting will stop. So we will say that the train has crossed over the bridge. We have to find out the time taken by the train to cross this bridge. So how will we see? We can have a look at these two diagrams, and we will see that the time will be the same as the time taken by the head to cover a distance of, the head was at this position. Finally the head moves at this position. So the head has covered a total distance of L plus capital L, which is equal to the sum of the length of the bridge and the length of the train. This distance is being covered at what speed? At a speed of v meters per second. Now from the basic principles we can say that v meters are covered by the train in how many? In 1 second, because this is the definition of the speed, v meters per second. 1 meter is covered in 1 by v seconds, and L plus L meters are covered in L plus L seconds. So the time taken by the train to cross to the other side is same as the time taken by the head of the train to cover a distance of L plus L, and the speed at which the head is moving is the speed of the train, that is v meters per second. So the time taken is, as we have derived just now, L plus L by v seconds. We can put it in simple language as sum of lengths of train and bridge divided by the relative speed of train with respect to the bridge. This is a most general form. Sum of lengths of the train and the bridge, that is L plus capital L, divided by the relative speed of the train with respect to the bridge, which is the same as the speed of the train, that is v. This is the most general expression, and the formula in terms of our variables would be this one. This is one thing that you can remember. Next, let us take the case of two trains crossing each other. Let us suppose this is one train of length L that is moving towards the right at a speed of u meters per second. And let us say that this is another train of length L which is traveling at v meters per second towards the right side. The above train is also traveling towards the right side. We have to find the time in which this train of length small l will cross over entirely the train of length capital L. We have to find out. If you see, in the case of bridge, the story was the same, but the bridge was fixed to the ground. But in this case, this we can say a bridge that is already moving. So we have to find out the time taken by the train to cross over a moving bridge we can say a sort of moving bridge. So that is the basically we have to derive a general formula for that. Let us start doing that. This is the starting position we can draw here. This is one position L and this is small l, the head of which has just touched the tail of the other train. From this position we have to move to this second position where the tail of the other train touches the head of the first train. So basically we have to find out the time taken by this train of length small l to move into this position where its head has covered a total distance of L plus L. The total distance will be L plus L only in this case also. L is this part and L is its own length. So this head has to travel a distance of L plus L, and in this case the first train of length capital L is also moving. So that moving effect has to be taken into account, and let us see how we can do. The distance moved by this train L in 1 second to the right side is V, and during that 1 second this train of length L also moves towards the right side, decreasing the effort of this train of length L by how much amount? It decreases it by U amount. So the effectively we can say the distance traveled by this train of length small l in 1 second will be V minus U is covered in 1 second. And we already know that the total length to be covered is L plus L. So that is a simple calculation now. 1 meter will be covered in 1 by V minus U, and L plus L will be covered in L plus capital L by V minus U. This is what is the formula. This is in seconds. So the time taken is the sum of the lengths of the two trains. As in the earlier case it was the sum of the lengths of the train and the bridge. Bridge was not moving. And in this case the numerator is the same as in the earlier case, the sum of lengths of the two objects. The division is by the relative speed. It was again the relative speed in the case of a bridge, as we already noted a few seconds before. Now V minus U is the relative speed of this train with respect to this train. The relative speed is the difference of the speeds because the two objects are moving in the same direction. So in common language we'll write the time is sum of lengths of the trains divided by the relative speed of faster with respect to slower train. So this is what is the whole story. The formula is exactly the same. If it is a bridge then it is not moving at all. U is 0. So if you substitute U equal to 0 in this formula, what will you get? You will get L plus L by V, which is the same formula as we did for the case of a bridge. Basically the denominator is the relative speed of the faster train with respect to the slower one, and the numerator will be the sum of the lengths of the two trains. So this is how this formula works. One formula can solve all cases. Now let us take up some example to understand it in an example form. Two trains of length 125 meter and 175 meter coming from opposite direction cross each other in 10 seconds. So in this case one train of length 175 meter is coming from this side and another train of length 125 meter is coming from this side. They cross each other in 10 seconds. So we can take this train as our primary train. This train crosses the other train in 10 seconds. So we have already been given t is equal to 10 seconds. How much distance does this train have to cover? The distance to be covered is d equal to 125 plus 175. So this is the distance that has to be covered, which is equal to 300 meters. This distance will be covered at a relative speed of how much the two objects are moving against each other. So the relative speed will be equal to the sum of the speeds of the two objects. Speed of one of them has been given as 36 km per hour and the speed of the other has to be found out. So as we have just seen a generalized formula that the time taken is equal to sum of lengths divided by relative speeds of the two trains, we can write it as sum of lengths has already been found as 300. So it is 300 divided by the relative speed will be v plus, now this 36 should be converted into meters per second. 36 kilometers per hour will be multiplied by 5 by 18. This figure will convert it into meters per second, so which comes to 10 meters per second. So this 36 kilometers per hour is same as 10 meters per second. We'll put it 10 meters per second here and we get t is already given as 10. This is equal to 10. Now we have to simply solve it. 300 is equal to 10 multiplied by v plus 10, which implies 300 is equal to 10v. 10 multiplies to this and 10 to 10 is 100, which implies 300 minus 100 is equal to 10v. This 100 is brought this side, which implies 200 is equal to 10v, and which finally gives v is equal to 20 meters per second as the answer. So this is how we can solve this. We'll take more complicated examples in our next lecture. Thank you. Chapter-wise list of all my videos is available at this point. For DVD, pen drive, please write an email to me. These videos, they do not require internet, they play offline, there is no problem of buffering. And please subscribe to my channel for regular updates. Thank you for your support once again.